Edge Lake is essentially a data store that runs at the very edge of a network. So, in other words, when I'm connected to industrial computers, industrial controls, literally the edge, that data that's collected from the PLCs and other industrial devices, sensors, etc., stays at the edge. It does not traverse a network. It does not move anywhere. It stays literally next to where the data is being collected. And what ends up happening, instead of moving data, we create a single interface so that you in one spot send a request to retrieve data. We understand where that data is in an environment and then distribute the queries to where the data is. And then the queries come back, only the result sets come back instead of all the raw data. So that's the biggest differentiator of how EdgeLake works versus other data acquisition platforms. We have connected an MCP to our environment. So what ends up happening, instead of having to centralize all the data and run your AI requests to it, I literally can leave the data at the edge, push the AI request to the data at the edge, and have it satisfy the request without having to centralize all that data. In the example, I actually used Claude to generate this diagram. This is actually connecting to our MCP at the edge. I'm connecting to this machine right here. And I asked it to diagram the network topology of environment. So we have 3 different machines collecting data at each site. So I don't have to push all the raw data anywhere. I request through the MCP what I need, and the MCP then pulls using the ANYLOG protocol, pulls the data, the result sets come back, and feeds the AI that's requested through the MCP. I ran queries, create a real-time dashboard to show the current status needed and operational data for the running of that unit in HTML only against the MCP. So this is the dashboard that I requested. As a result, is the Unit 250 bioreactor. You're seeing critical parameters that are being collected for that bioreactor. You see the batch that's processed, the formula that's being processed, flow controls, the performance and uptime of that process. And then on the right, you see the live queries being executed against the MCP to collect this data. Claude connected to the MCP, gathered what's called unified namespace. And unified namespace is a way of describing data in an English way. So raw PLC data comes in with just tags and is not very useful. So it looks at the raw tags from the PLC and created the namespace that you saw. So that UNS is now able to be used, so I can actually tell what process is being run, what batch is being run, what the sensor types are, and what the values obviously are. The other interesting thing about EdgeLake is that it doesn't need any DBAs. So when you connect it to a southbound data source, it will automatically take the raw table data coming in and save it to a table. So what UNS does is when you apply it after you get the raw data coming in without having a DBA to define table structures, it then associates English, or it associates a hierarchy of processes with the raw data table so that you can refer to it in a well-known way without having to worry about where that raw data is stored in the system.
So, taking a look at this, Mark, first of all, it seems kind of like magic. You hardly told it anything, and it actually created
Exactly.
a
That's
comprehensible
why
dashboard, color coded, easy to understand, surfacing all of the data in real time. Um, So if I wanted to use this going forward, if I wanted to persist that, what would you do?
This is an HTML file. You just run the HTML file and it connects to the MCP and pulls the data.
So you wouldn't need Claude once
You
it's
don't need
generated?
Claude. No. So here's another dashboard I did. One of the other interesting things, there's a metric in manufacturing called OEE, Operational Equipment Effectiveness. OEE is the kind of like the metric that they use. It measures quality, parts produced, and downtime. So the higher your OEE, the better. We're getting raw data tags from the PLC in this example in Enterprise C. So what I had Claude do is I said, calculate OEE for each process and give me an overall OEE calculation and find issues that is affecting OEE. So I did that in the prompt. It looked at the processes, shows where it is, shows the OEE. Again, I didn't tell it what metrics to collect to calculate OEE. Claude did that for me. So it looks at the three processes and the plant average, and then it found the issues affecting OEE. In this case, you see a column pressure spike, so that affected quality. So it affected OEE by minus 3.2%. So you could actually see exactly the problems that occurred and how it affected OEE in this example. All the MCP does is queries to the data. We're not putting OEE in it. It's just querying the data and then letting the AI do all the inferencing.
It's a combination. What works here is combination of two things. One is the ability to reach out to the data wherever it is. So we've got a lot of distributed data, but nevertheless, when the MCP asks something about the data, he could see all the sites. He could see all the data regardless where the data is. The second thing is something that we recently added that fits the MCP, and it's what Mark called the unified namespace. And now when Mark asks to calculate OEE, he sees two things. He sees all the data, but he also sees the logic, the asset framework. If you are familiar with Aviva Pi, it's called asset framework. He could drill down, and Mark could show you how we could drill down hierarchically using the namespace to reach out to the data. And it's really the combination of the framework, the asset framework, and the data that creates this functionality. So there is here, Mark could show you, we could drill down now, not only using relational, using queries, but we could drill down using the asset framework into the data, which is very much like every historian. But here, the data is not centralized, it's distributed.
Using the UNS, I can drill into the site, the process, the sub-process, the tank, and then I can look at the data associated with that tank. And then if you hover, you see in that pop-up the UNS space, Enterprise B, Site 1, liquid processing, tank storage, and then that automatically associated with it with the tables that was automatically generated by EdgeLake when it connected to the southbound data source. So I don't need to worry about this data is in lot number 16. What I need to worry about is show me all the tank 6 data. And it would understand all the tables associated with it and pull the appropriate data. Here is the bioreactor. And I said, show me the issues and errors that I got from the bioreactor and correlate them. So what it is, it's refresh now. Let me start the auto refresh. What it's doing, it's looking for PLC issues in the raw data. and it automatically categorized critical alarms, warning info, and alarms that automatically resolved itself. It literally created active issues and errors acknowledgement alarms so that I could acknowledge them, I could resolve them. All that was done through literally a prompt saying, show me issues and errors and correlate them. I integrated network data along with system data, along with application data. And I said, show me data gap correlation if there's a network error or a systems error. And it literally starts showing how many records are lost and why it was lost.
What is the benefit compare with about centralizing data architectures? Centralized data architecture means about the store data on the one side, for example,
Right.
using a cloud. Yeah.
So if you centralize it, I have to push everything that's collected at whatever frequency rate that you have to a central site. Everything. In this case, I push nothing. I only get the data when I need it.
So for kind of on the business side, it's huge cost savings. The second thing is real time. If you move all the data first to the cloud, real time is no longer there. The complexity is huge. You lose ownership of the data, right? If you are an industrial operator, you have to give your data to a third party in the cloud. There are lots and lots of reasons. The companies move their data to the cloud or to some centralized place, not because it's a great solution, but because managing the data where it's being created at the edge is complicated. And that's the problem that we saw. The data needs to be where decisions are being made on the industrial floor. But to do that, your option is to send engineers that would build data platforms on the industrial floor, aggregate the data, unify the data, create tables, create schemas. With EdgeLake, all of that is gone. From start to end was a completely automated process. Zero lines of code.